What's up, Jay?
Hey Nate, how you doing?
I'm doing well. Ready to dive into this podcast.
I am too, and I'd like to just frame it before you really go deep into some of the research you've done and some of the analysis. So I had the opportunity to go over to the Capital Factory here in Austin this week, and I really went because I wanted to focus on a session they had on brain-computer interfaces. And as we look at how the human mind can start to interact with the technology around us, and I went there because I wanted to tie it to the discussion we had last week with Matt Daly, because we talked about a concept of living intelligence as a follow on to embodied AI. And with embodied AI, we were talking about the ubiquitous sensing, the edge computing or processing, the data that's generating, and how AI is starting to converge with the physical world and machines. But the part we didn't discuss last week is how ubiquitous sensing and edge computing or processing and AI are converging with bioengineering and how that's going to drive the human experience. So the focus this week was really hearing what some of the leading edge thinking and industry activities are around brain computer interfaces. But I'd like to take a step back, look at what we did for the most recent report, the analysis you've been doing, and how that ties together with this collision of AI or digital world and the biological world.
Yeah, and Matt's conversations last week were phenomenal. I highly encourage you to check it out if you haven't heard that yet. The We're building upon that in terms of embodied AI, and we're gonna think about like the technology, right? Like smart technology. But what if the technology wasn't just smart? What if it was alive, right? The lines between biology and artificial intelligence are blurring, and they're blurring faster than we think. The example I'll give you is, cortical labs. Cortical labs, for those that may or may not know what they are, in 2022 they built this dish brain. Right, it was human neurons on a chip, and they taught it to play Pong. And so, if you don't know who Cortical Labs, I'm sure people have seen the article where a brain computer played the game of Pong. That was 3 years ago. In March of this year, they launched the CL1, which is the first commercial biocomputer, right? It is a computer powered by neurons, not silicon chips. And that's pretty awesome. And then in May, they announced Wetware as a service, which allows developers to access these biocomputers through a cloud, the cortical cloud. And so you think 3 years ago, we were putting neurons on a chip, which is phenomenal in a really incredible development, and teaching it to play Pong. And then in March of 2025, 3 years later, you can actually buy a biocomputer, the CL1. And then 2 months after that, you can don't have to buy the computer. You can access their bio computing cloud, and you can run tests on it. This is really remarkable for a couple of reasons. One, it is that merging of technology and living intelligence in life, right? It's the biotechnology in terms of what it can do in our human bodies, but also bringing that computer alive. But it allows potentially for a decreased power consumption, right? So the human brain, it runs on the roughly equivalent energy of what it takes to power a light bulb. It's nothing. And so as Cortical Lab announces this wetware as a service, there's this potential to have biocomputers run on vastly lower power than current data centers. And so data centers right now, right, they consume a bunch of energy. It's actually a problem we're trying to solve in terms of we have this insatiable appetite for data to run AI models, to run these large language models, to run what AI is going to be in the future. We're exploring small nuclear reactors. They're reactivating dormant nuclear reactors. Facebook, Google, these companies are looking at how they power these data centers. If you can build a biocomputing center that's powered by neurons, the energy requirement is much less. And so, well, we're simultaneously exploring, hey, how do we increase our power output? This company's exploring, how do I create a computer that can do the same thing with less power required, which is also kind of interesting. And there's other implications, but I think just that concept alone is pretty crucial to what this tech is going to potentially provide for us.
There's also a remarkable efficiency in what you described as well. We took a look at the ability to store data in DNA and the density of data storage on DNA folds versus traditional data storage, like we see, whether it's clouds, local drives, and things like that. It's a remarkable increase in efficiency there as well.
Yeah, you can store the entire collection of human data onto a DNA strand, right? And that's a lot of data, and that's a really, you know, small that you can't even see a DNA strand, but the folds and how that works, right? It just shows you that, as we get really advanced in how we, design things and how we create things, we're pretty awesome. We're still nowhere near the efficiency and the beauty of what nature has provided. And that's a comforting thing for me as we, progress and advance. We're still behind the ball when it comes to a competition with what nature can do.
You are not joking, Nate. And we had previously talked about how science fiction is remarkably prescient in a number of different ways. Two ideas come to mind as you're describing this. One, I'm thinking of the Borg from the Star Trek series and
Yeah.
how the humans and the machines and the community, everything just becomes this collective entity. You had mentioned the Matrix earlier. And as I'm thinking about this, like we're literally seeing the physical convergence of human existence and human experience with the technology around us. And there's no longer this dividing line of like a watch on your wrist or a pair of glasses on your face, but it's going to potentially become in you or potentially part of you even. And the thing that really comes to mind, and you'll have to forgive the pun, but there's a lot of upside to this, what you described. Density, we could very well target human health with a higher degree of precision and certainty. But there certainly seems to be a dark side as well, with some vulnerabilities as this line between engineering or the mechanical and AI world blurs with the biological world.
Yeah, you're putting neurons onto chips, right? They take neurons, they cultivate them inside a nutrient-rich solution, and they provided everything it needs to be healthy. And so we're really blurring the lines on what it means to be alive, right? Now, we're not there yet in terms of like neurons that live on a silicone chip that have a 6-month, shelf life, because we can't keep them alive. But eventually, we're going to get to the point where they're enduring. And so, what if this computer that can run AI functions on it creates something, right? Like who owns the IP for that? Who owns the idea, right? Like if I'm the programmer giving it the code and doing stuff, but this, biocomputer is the one that's creating it. Like you could probably make, I'm sure someone will make, right, the argument that that belongs to that computer and try to, make it an entity. People are already doing this with inanimate objects, right? There's a guy that married a car a couple of years ago. It was a YouTube video. I'm sure it was just for clicks, but people do make ridiculous arguments. But this does cross a little bit of an ethical boundary in terms of how we think about computers, how we think about artificial intelligence. There's like artificial life, and I'm interested to see where this goes. There's also like the concept of wetware, right? We have software, but this is wetware. It's tapping into these biocomputers at a scale that we haven't seen because it hasn't been done before. And if we got these wetware services in terms of not just a cloud service, but a bio center, there's the power consumption side of this, but also potentially greater compute because of the efficiency of a neuron. And I think that's incredible, and especially because they're offering this service currently in a comparable price to what a Zoom subscription costs. And so there's some rapid developments going on here. The other interesting part of this is there's another company I was doing some research on. It's called Nitri. It's a French company. We've talked about them previously, and we featured them in the report. What they're doing is they're creating organs on chips. They call it organ on chip, right? And it's technology that they're using to predict drug safety and effectiveness, which reduces the need for animal testing. So that's huge in terms of how you do this ethically. There's lots of discussions on is it ethical to do drug tests on animals, and potentially Nitri is going to remove the requirement for that. In February of 2025, they opened an industrial scale factory in France to mass produce these chips. And in March, they acquired HCS Pharma that expands their capabilities in creating these different organ models. And so that's pretty cool for a couple of reasons. One, mass producing organ on chips. I still can't comprehend what that looks like, but it allows us to do rapid and mass testing of different drugs, right? And so instead of saying, hey, I need a human trial for ibuprofen to see what it does to the stomach, or I could just mass produce millions of organ on chips that simulate a stomach and do the testing for that ibuprofen model. It's a greater way to scale the efficiency of drug testing, which has some awesome ramifications in terms of safety of pharmaceuticals. There's also that darker side, which I love exploring, the good and the bad, right? So if I can produce an organ on chip and I can put neurons in a computer, we're probably not far off from a living computer, right? I think of Data from Star Trek. And I know it was a human actor that was walking around, but that wetware software, organs on chips, neurons on computers, like we're rapidly moving towards a convergence here, which could be exciting and could be kind of terrifying.
Yeah, so I'd like to go back to one of the ideas you presented, and that is as we start to look at the data that we will be generating through our thoughts, through our minds, through our actions, and how that could be utilized. So the idea that comes to mind to me is, and this is probably more, it's got an upside and a downside. Um, so think about the ideas that you have that you lose, whether it's in a dream or you're in the shower and you have a good idea, you don't have pen and paper nearby, you don't capture it necessarily. You get these fleeting ideas, those moments of creativity. We're already seeing the challenges with AI and large language models studying people's work and the blurred line between whose IP is it when an LLM ingests it. And then now we're seeing what's the creator economy going to look like as LLMs continue to generate and other versions of AI generate products. Here's an interesting idea, though. I mean, an upside is this potential data store and the wetware you're describing and things like that could very well be a method to capture those fleeting ideas and have a store, especially like your dreams. You might, who knows, you might have some incredible ideas about solving some major problems during a dream that you don't even know about if you don't recall the dream when you wake up or you can't contextualize the dream. But what happens if it's such a good idea and that data isn't necessarily locally stored, but it's piped off to a cloud storage and someone's mining or monitoring that data and you lose control of that idea that you didn't know you had in the first place because of this completely blurred line between your mind, the ideas you create, and then the data that generates and how that connects. And then on a downside perspective, so I think that's a small downside. How do you control your ideas when your ideas are now part of a data store in or around you? And the other idea that comes to mind to me that really concerns me is if you look at all the nefarious actors, just with the basic hardware and software technology we have right now, ransomware, malware, corrupted data, viruses, and whatnot. Imagine when there's no longer some physical differentiation. It's frustrating if your computer gets a virus, but imagine if your brain gets a virus. And I don't mean a traditional biological virus, like a computer virus infects something that's embedded in your physiology as a human being.
Yeah, a couple things to unpack there. You mentioned, capturing your forgotten ideas. And I'm going to go ahead and say this on record. I've had the best ideas that I've never written down or, I've forgotten about. Just going to put that on there. I think I can maybe trademark that or capitalize that in the future. This is a parallel to what we talked about last week with Matt in terms of Google XR is rolling out these glasses pretty soon, right? That are going to be pretty remarkable in terms of the ability to remember things in terms of a physical environment. So you can be looking around and be like, man, where did I put my room key? And you can ask your glasses that and be like, hey, the room key's behind you on the shelf. And so I think you're getting at a similar idea of like, hey, what was that idea I had 3 weeks ago when I was, laying in bed? It's like, well, this is what you were thinking. I would love to see if we could get to that. That'd be useful to me. But there's also, that question of, who has access to that, right? Because if you're going to put something on you that's developed by an external entity, there's, I really would probably read the fine print for that user agreement pretty detailed, just because, I'm okay, I think, just because of how I've grown up, transitioning from the 80s to the development of the internet and to also, rolling out cell phones. Like, I don't even read the user agreements on my cell phone anymore. I've accepted the fact that I'm going to give away a certain level of privacy to have the convenience of technology. But it's external. I can forego my cell phone. If you're putting something inside of me, you can't really forego that, right? And so that's a question that I'm interested to see how people ask, or even if we ask it. Going to, I think, a different direction in what this means. If you're able to do the neurons, you're able to do the organs on chip. We're not far off from doing a complete body simulation, right? Like I can create a simulated human being. And the benefits of that are I can now run millions and millions of experiments rapidly in all kinds of different environments, right? You know, think about this just off the top of my head. I want to see how a human being responds to this drug. And I want to see if it actually does the things that I think it's going to do, and it's as effective as I think it is. And that's pretty awesome. I want to see if this person I can simulate. I'll simulate Jay Maselli, and I'll give him this disease, and then I will give him this drug to see if it eradicates that disease. So now I got a little bit of a personalized medicine for you. Or I want to see what it looks like if I put a human on the moon for an extended period of time and I run them through these environments. And I have not just a digital simulation, but a organic nuclear physical simulation that I can then run some more advanced tests on. There was James Bond, one of my favorite, movie franchises. In one of the more recent James Bond, Spectre designed this genetic bio drug, bio bomb, bio weapon that basically you could target DNA of individuals and it would kill just those individuals, right? And so you were talking about nefarious actors and this technology, which is going to be ubiquitous, that you really can't control who gets a hold of it. There's potential to use it in a really horrible way, which is, hey, I can run some tests on, does this virus or does this drug or does this weapon target the people that I want to target? Well, not targeting those that I don't. And so, like, yeah, I think that's the, catch a falling knife of tech. It's going to do awesome and amazing things for us, but there's unintended consequences, or there's some nefarious consequences that are going to come to this. And we have to build the structure that controls this in an ethical manner. And that's why I think it's important for who wins. It's important for who has access to this and who develops it, because that's going to drive how it's used.
That's a great way to frame it, Nate. The way I'm thinking about it is that your last point is we've got the opportunity to take an engineering concept of the digital twin and map it out to a physiological twin, and that can be used for remarkable good or remarkable bad. And I think just my final comment is that clearly, and I'm going to take a term from our report, this convergence of advancements, these rapid advancements in computer and hardware technology and biological technology, it's unprecedented. And I think it's the first time we're truly seeing these worlds converge into what could be one single hybrid entity in the future.
Yeah, and talking about the future, like what's next? So, what is these two companies we talked about? What does this mean, right? These are just two, and I'll briefly hit a couple other ones. But next 1 or 2 years, right? Scaling up from a single biocomputer that we talked about with, the CL1 to the first bio data centers. We talked about the potential energy benefits from a bio center, right? 3 to 5 years, expanding applications to include adaptive robots and complex human on chip, not just organ on chip models that allow us to simulate the entire body. The challenges that come with both of those things, right? You have a computer that runs on neurons, you have to keep the neurons alive. And so there's this huge, if you have a large neuron cluster, you have to feed it. And you feed it in a vascular-like system, right? Air quotes. But it's basically like you have to simulate the body's blood flow to keep these neurons alive. And if you can do that, then we're really close to, having that thing walk around, which I'm sure has some benefits and some potential pitfalls. The technology challenges, right? Improving the ability to send information and receive it from those neurons, it's an I/O problem. Like you can create them and you can put them on there, but now you have to do the in and the out. And we've got a really good model for that on a silicone example, right? We know the ones and zeros. What does it look like when it's alive, quote unquote? But the ethics of this also is a huge challenge, right? Creating the regulatory and ethical frameworks to address the questions of sentience, of data rights as the technology advances, I think is going to be an interesting discussion. A couple other companies that are doing some awesome work here. Final Spark, they're doing a biocomputing cloud. They announced this year that they're getting better at mapping the direct high-speed wires between the neurons, which fits into the CL1 and the biocomputing and the bio data centers. Axon Biosystems looking at providing the essential hardware to the materials. I think of this as like during the gold rush, right? People are like, hey, invest in, put money in the gold rush. It's like, no, buy the people that sell the picks and shovels. Because, that's a known demand. You're not going to necessarily find gold. So I think there's some awesome developments that are on here, and I'm looking forward to seeing how this goes. Like the growth from 2022 to I play Pong to, hey, I can access a biocomputer through the cloud, through Nitri, like, hey, I got an organ on a chip. Awesome, that's cute. No, I'm mass producing them. It's 2025 shaping up to be a pretty remarkable year, and I'm interested to see what the next 5 years develop and the conversations around them. Not just the tech, right? The tech's interesting, but we gotta wrap this into an ethical framework.
Yeah, Nate, these are incredible insights. And as always, I really enjoy our conversations. 2025 is, and I'm not being trivial at all when I say this, seems to be the continuing saga of the expression, may you live in interesting times. Because, wow, this is quite the interesting development in this convergence. And I think my personal takeaway from this discussion is, previously we were talking about, hey, you're generating all this data. Are you the driver? Are you the passenger in the world of embodied AI? When cars start driving themselves, making decisions for you. I think what's really interesting to me with this discussion is not only are we producing the data, but we're going to become the data stores. And then the third element of that is going to be, and then who's going to make what decisions with the data that we're generating and storing. So we're not only producing it, we're storing it, and then we're still going to inform some level of decisions either on our behalf, with us involved, or without our consideration.
And potentially, there's going to be a semi-sentient entity that's going to produce its own data. And so, what does that mean?
That's true. Yeah, though your data production isn't just your physical being, the sensors on or around you and your mind. It's now going to be this potential sentient embed that's part of your existence as well. Yeah, I think we've got a lot to explore here in the next couple of podcasts coming up, and really enjoyed the discussion, Nate.
Yeah, absolutely. We're going to revisit this for sure. So, always good talking to you, Jay.